Welcome everyone. We are about to explore today's topic called data structures and algorithm. As you know, the backbone of smart data systems. So here is the roadmap for today's sessions. So we will discuss the importance of data structures and then the role of algorithms, then how they work together and common types of data structures used in real world smart applications, and finally current challenges and what the future holds for this world. So let's get started by understanding why data structures. Let's start with a very simple question. Why do we need a data structure at all? Let me give some example. Think about your phone cache memory. Have you noticed that when you open an app for a second, it loads much faster than it did the first time, right? That's not a coincidence. It's because the app is storing some of its frequently used data in the smart way, right? It might be using a hash table or even a stack to keep a track of what recently used. So it does not have to go to the through everything again from the beginning. So that's right there, a data structure in action. So what exactly a data structure doing? So we can say data structure simply organized a way to store and manage data so we can access and use it efficiently. When we pick the right one, we save memory, we speed up performance, and we make our system very smarter. And also I'll give one more example. If I just need to store a list of items like students names or product price, I would have probably used an array, right? It's a symbol, and let me access elements directly by position. But if I don't know in advance how many items I'll need to add, or if I need to keep inserting and deleting data frequently, then an array won't be enough. So we have to use something like linked list. Now let's say I want to model something with a parent child relationship, like folders inside your folders on your computer. A tree would be perfect for that. As we are if you are dealing with the system where everything connects to everything else, like cities and roads in Google Maps, we use graph to model those connections, right? So this is why the data structure is very important. Okay, let me ask one more question. If you had to store student records and you wanted to access any student's data instantly just by their roll number, what kind of structure would we choose? Think about that. Obviously we have to go hash table, or maybe even we can use array, because both let you to access the data directly and super fast using a key area or an index time. So coming to the role of algorithms, so now that we have seen how data is stored using a data structure, right? I'll ask one question. How do we actually process or use the data efficiently? So this is where algorithms comes into play. Okay, so algorithm is nothing but a step-by-step procedure to solve a problem. For example, it's like a recipe you follow to get something done. Only in computing, it helps us solve tasks like sorting, searching, or navigate through data. So we'll see some example like when you arrange names alphabetically, say in your contact list or a student role, that's a sorting algorithm at work. Okay, some common ones are quick sort, merge and merge sort. They are designed to sort large set of data very fast and efficiently. Okay, now think about searching. Like when you open your phone contacts and start typing a name, the phone is quickly narrows it down, right, and shows exactly who you are looking for. That's often done by using binary search, which is a very efficient way to search sorted data. And coming to Google Maps, when you want to go from your home to a restaurant and you ask for a direction, the algorithm behind the scene calculates the shortest path using the graph traversal algorithm. Again, step by step logic working through a data structure. So now you can think of data structure algorithm like hardware and software. They are built of each other and they work best when used together. Okay, we will see some example. If you want to use binary search, your data must be sorted and ideally stored on array. Okay, if you use a linked list instead, the algorithm won't perform well because it might even become useless because it cannot jump to the middle directly. Okay, so to solve the problem effectively, we have to choose the right data structure and pair it with the right algorithm. Okay, if the structure is wrong, even the smartest algorithm won't give us good result. Okay, let me see one more example. Imagine you go to a library. Okay, the way the books are arranged, that's your data structure. Okay, so maybe they are organized by authors or subject. The way you go about finding the book you want, that's the algorithm. So you might search by using a digital catalog or check the label section by that. So the structure helps store the data and algorithm helps us retrieve and use it. Okay, coming to common data structure in smart data. Now let's now look at how this all plays out in real world smart systems like the one we use every day. Okay, if we take a sorting, uh, website like, right, website like Amazon or Flipkart deal with thousands of products today. So the moment you choose sort by price, low to high, the system quickly arrange all those items in order. Behind the scene, the algorithms like quick sort or merge sort are doing that work instantly. And choose does it this matter because sorting means faster user experience. Okay, which keeps customers happy and more likely to buy, right? And coming to searching, as I said earlier, say you are typing a friend's name in your phone, even before you finish typing, the right names pop up. That's because the phone is using binary search or some other optimized searching algorithm on a sorted list. So what amazing is the binary search keeps cutting the search range in half, right? So until finds what you are looking for, it's quick even for a huge data set. Okay. So coming to the challenges and future trends, as we move into more advanced system, the challenges we face are also growing, right? So we are not just working with the megabytes of data anywhere. So we are talking about terabytes and even petabytes, right? Think of the platforms like YouTube, Netflix, Amazon. They are dealing with millions of user action every minute. So one major challenge is big data. How do we store and manage all that the information efficiently, right? And another is real world performance. Uh, think about today's like fraud detection in banking. The system has to decide in millisecond, right, whether the transaction is safe or suspicious, right? So that demands faster algorithm and highly optimized data structure. And also we are working with parallel and distributed computing. Our code has to run on multiple processors or servers at once. That means we need algorithms that are smarter even to divide the work and run parallelly. Then we have emerging fields like AI, IoT and blockchain. If you take AI, we use graph neural networks to learn complex patterns, right? And coming to IoT, we rely on queues and circular buffers to process sensor data in a loop. And coming to blockchain, we use trees like Merkle trees, right, to verify the data quickly and securely. So we will see more adaptive data structure that adjust based on the situation, more energy efficient algorithm and smarter way to handle real time data structures like the ones coming from your smart watches, cars or home device. Okay, thank you. Thank you all. I hope this session helped you to see how data structure algorithm are not just a theory, they are invisible power behind the smarter system used every day from your phone to the cloud. Thank you.